Welcome. In this session, we'll learn how to write script files or M files in Matlab. So what's a script file? Script file or M file are simply a blocks of code or set of instructions or commands that you can execute in one go. In other words, these are the programs that you can execute, that you write in Matlab. So our goal here is to see how do we write programs in Matlab that you can execute in one go. Now to illustrate this, how do we write script files or M files in Matlab? Let me take an example of from a communication. Let's suppose we want to see this amplitude modulation in this Matlab. Now, so to do amplitude modulation, we know there are two signals are there. One is the message signal and another is the carrier signal. Then we do perform one kind of an addition between the message and the carrier that we shall see in the modulator. Now, first of all, what are the parameters of this message signal? We have the amplitude of the message signal and the frequency of the message signal. Same way, we have the carrier amplitude and carrier frequency. Now, to obtain the amplitude modulated signal, simply obtain this AM signal. What we do, we perform this addition, means we add the carrier amplitude with the message signal and multiply this added signal with the this carrier signal. We obtain the amplitude modulated signal. Now, to illustrate this M file in Matlab, what I'm going to do, I'm going to first do it on the in command window. Then to illustrate what's the advantage of using M files or script files in Matlab, we shall see this next. Now, first, let me create this amplitude modulated wave in command window. Then we shall do the same thing in this I'm using M file. So let's write the amplitude of the message signal as 3, amplitude of the carrier signal as 10. This is just an illustration. You can take any value. And frequency of message signal, let's take 10. Frequency of carrier signal, let me take it 100. This is just an illustration. Now to create a time window, let me take the time axis from point 0 to, let's suppose 1. Let's illustrate it for this time window. Means next, what I'm going to do, I'm going to create the message signal. Let's name it message signal. So this will be AM times sine of 2 pi FM times T. So this will give me the message signal and it will be stored in the array MSG signal. Same way, we'll create the carrier signal. We'll name it CAR SGNL carrier signal AC times sine of 2 pi FC times T. So this will give us the carrier signal. Then to obtain the modulated signal, let's call it MOD, modulated signal. We do the addition like AC plus message signal. So this will add the carrier amplitude with the message signal. Then we do the element wise multiplication with the carrier signal. So this is 2 pi FC times 2. So this will give us the AM signal. Now to plot these, we are going to plot all these waveforms, means message signal, carrier signal, and this AM signal. So to do this, to have the plots on the same window, I'm going to use the subplot command of Matlab. So we'll create 3 plots, and these will be created in 3 rows, and this is the first plot. Now I'm going to I'm going to do the plot of the message signal. So this will give me the message signal. Next, what I'm going to do, I'm going to turn the grid on, and I'm going to label this plot as message signal. So this will be plotted on the first window. Next, I'm going to do the subplot 3, 1, 2. So this will be plotted on the same window, and this is the second plot, and I'm going to plot the carrier signal on this. So carrier signal will be plotted on this, and I'm going to name this plot as carrier signal. Next, I'm going to plot the modulated signal. So I'm going to plot the modulated signal, and I'm going to name this plot as AM signal. And this amplitude modulated signal. All right. Now to see this, this may not be visible to you. Now let me switch to the figure window. Now you can see this is our message signal. This is the carrier modulated by this message signal, and this is our amplitude modulated signal. You can see, yes, indeed, this is AM. Now you can vary the frequency and the amplitude of these waveforms to have different plots, to have look these plots, to vary these plots. All right, so this is just an example. Now what I'm going to do, I'm going to do the same thing using M file. Now to open M files, these script files are written in editor window, and to open an editor window you have to just click on this new script on your window. Just click on this. If this is not visible, there will be file on this. Just click on the file, then click on new window. That will open the editor window. Another way to do the same is if I click this opened, and I hope this is visible to you. Yes, okay, this is visible. So this is our editor window, or I can open this editor window just typing edit and hit enter. This will open the editor window. All right, so what I'm going to do, I'm going to do the same thing using now the script file. So first I'm going to define the time duration for which I want to see this. So this is the time duration, and you can also write this here, just writing part time duration. So this won't be executed. This is the comment line. This is simply a comment line, means this won't be executed by the Matlab. Then I'm going to define the amplitude of carrier, amplitude of this message signal, frequency of carrier, frequency of message signal. So you can write it. This is the amplitude of carrier wave. This is the amplitude of message signal. You can say this is the frequency. So you can also type the information of this using the comment. And comment is obtained by writing this %. Frequency of carrier wave. Frequency of signal. And next, what I'm going to do, I'm going to obtain the message signal. So this is our message signal, and AM times sine of 2 by inside basis 2 by FMT. Then I'm going to write the carrier signal. AC and sine of 2 by FC. So this is the carrier signal, and you can write this. This is carrier wave. And this is our. Remember, this won't be executed by Matlab. This comment line won't be executed by Matlab. And I'm going to obtain the modulated signal or amplitude. And you can write, let us name it AM signal. I'm going to write the amplitude of the carrier. Then I am going to add to it message signal. This is our message signal. Then I'm going to the element wise operation of this. So this is our AM signal. Then I'm going to do this plot, subplot, 3,1. So this will give me the first plot. Then I'm going to plot on the first. I'm going to plot the message signal, and I'm going to name this plot as message signal. Then I'm going to copy this. Right. Second, this is carrier signal, and AM signal. Modulated signal or modulated wave. All right. Now next, if I hit run, this will be executed. But MATLAB will first ask you to save this. So you can either do this just clicking the save, and remember it will be saved as .am file. So AM signal. Sorry, amplitude modulate. Let's call it AM. Right. So this will be saved as am.m. So it will be saved as, you can see the name am.m. You can see a file is created here that's named as am.m. Now if you hit enter, run, this will be executed, and you can see the plot. Now this is executed. You can check on the command window, am appears here, means it's executed. This file got executed, and you can see this is the waveform. Now you can vary the amplitude and the frequency of these different waves and see the results accordingly. Now this is just an illustration. So what's the advantage of I hope this, I don't think so this is visible to you. Let me first share the window with you. So this is what we obtained after executing this script file. This is what we obtained from this. This is paused. All right, so this is what we obtained after executing this file. This is what we obtained. So this is AM. Now you can change the amplitude and frequency of these message and carrier waveforms. You will obtain a different result for this amplitude modulated signal. You know the theory better. All right, so this is just an illustration. So what's the advantage? Advantage is this. See, on command window, you have to write this code line by line and then execute that each line separately. But on script file, you can write the code together and then execute this. See, if I hit this, let me close the figure window. If I hit this AM, this will be executed. As this is saved already there, this will be executed. This is executed, and you can see the result. This is the result that you obtained. Now, if I change the amplitude, let me go back and change the amplitude of this AM to 5. Let me take it to 5. So 50% modulation, you know that. So this will be saved. Then if I hit enter, this is executed, and you can see the result looks like this. So this is AM wave. Now I have just increase the amplitude of our message signal. So this is the advantage of writing scripts. Or in short, in script we write a block of code or programs that you can execute in one go. So this is how we write script file in MATLAB. Now one more way to write scripts in MATLAB is defining functions. Those are called user-defined function. That we'll do next. All right, let me end this session here. Next we will learn how to write functions in MATLAB. All right.